Okay, let's get slowly started with the second part of the fifth lesson about interactive maps. And I would want to start by asking with those who are now online that is there somebody who's, well, don't have to be a wizard, but familiar with JavaScript in general or Leaflet JS in particular? You can raise your hand or put the green check mark. So today we will kind of get a quick, there's one hand. So good. So you can then correct me if I'm wrong with something. But I assume maybe you have not created. So there's one yes and one no. So might be that you haven't created leaflet maps via Python. So that's what we will be doing. So no, we won't be coding anything in JavaScript, which is basically a scripting language for adding interactive content on websites, such as zoomable maps. You might often see in the newspaper, there's a locational map if something has happened, or simple maps, and even then thematic maps, especially Helsingin Sanomat has been putting a lot of effort into publishing interactive content, including maps. So it's of course a good way to engage the audience, and there especially you need to think about the map elements a bit differently than when plotting, visualizing a static map. But in these interactive maps, we can also have multiple layers on top of each other. Often the basis is a base map from some of these tile providers. But you can of course then only have for example, polygons without any base map visualized. Yep. But we will use a Python package called Folium that then makes it easy for us to convert our geodata frames into these kind of leaflet maps. Or in practice, we will create HTML pages which then have this interactive content in there. Let's have a quick look of leaflet documentation if it gives us some additional information. So if you want, so for example, something like this is a very simple interactive zoomable map created using leaflet. You can zoom in and out. There's some point object with some pop-up credits and so on. So here are the basic elements, and we will learn during this rest of the class how to create a couple of different types of interactive maps using the data we already have. Yeah, what else? Maybe so far that I'm familiar with JavaScript and these different packages. So there's another one called Open Layers. I don't know how popular that is at the moment, but Leaflet is at least very popular and very lightweight and efficient library for creating these interactive contents, especially for that work on mobile devices. So all the maps that we will create today now and you will then create in the exercise, they should also work. You can then open the GitHub pages link on your mobile phone and see how that looks like, and share it to your friends and relatives and show the cool maps you have published online. Excellent. So then indeed on the Python side, Folium is the package that we are using, and the main purpose is to take data from pandas or GeoPandas or Python in general, and then convert those into leaflet maps. So it's of course good to understand a bit what all you can do with leaflet, but we don't have to know how to write JavaScript in order to create these interactive maps. But then of course, if you would do something more advanced or create applications and so then maybe yes, but we now as geographers are focusing on the data analysis side, and then this interactive map is one potential output of our data analysis workflow. In addition to Folium, there are other options for creating interactive maps. So you can explore those in here. For example, this Plotly Express Seems quite interesting, but I didn't have time to look through it in more detail. So if you want in this week's exercise, feel free to explore also these alternative libraries. You just need to install them on your own computer or in the cloud computer. Bokeh you have already met. And then this GeoViews, I think it's more for raster data. If I'm not mistaken, I haven't myself using this too much, but feel free to explore other options. But let's proceed with Folium. Again, in the Jupyter Lab, now it's the number 2 notebook. And we should have all the available tools installed in the environment. You can test that by running import Folium command. If not, you can then install Folium using Conda. Conda install channel Conda Forge Folium should work without too many problems. All right, I guess we're ready. So let's take a practical example and just create this very basic background image on top of which we can then start plotting the data. So in Folium, everything kind of builds on top of this map instance. So an object that then contains all the definitions related to the map. Now let's call it M for short. And then we can construct it by calling Folium.map. So capital M refers to the fact that it's an object that we are creating. And then I guess we could even do like this. If we print out the map, let's see what we get by default. I haven't actually tested this. So if we just create a map with Folium, we get the whole world with OpenStreetMap data on the background, license information created with leaflet, and then you can start zooming in and zoom into Helsinki, Finland, Kumpula, and so on. So you can see that the tile service that's providing the data gives us then more detailed data the further in we zoom. Not too difficult. Of course, then we want to adjust this a bit. So first thing to do is to define the location. What is the default zoom extent or zoom point of interest? And let's zoom the map in to somewhere in Helsinki. Latitude, longitude, those should be somewhere in Helsinki. See what we get then, correct? So we are on the right track. Then we can further, a bit similar than in the previous lesson, define the zoom. So zoom start, of course, as it's an interactive object, the zoom level changes, but like this, we can set the default zoom level. And here, at least I never remember by heart which way is, I think the kind of coarser, the bigger the number, but we can of course just test it. No, the other way. So if I'm 12, yep. Okay, so the bigger the number, the more detailed the zoom level. So our point is actually somewhere in near the border of Espoo and Helsinki. There we go. So those kinds of things you can then adjust according to your specific purposes. Then, of course, as we mentioned, the kind of cartographer's checklist would be good to have, for example, a scale bar. You should add how to add a scale bar to the static maps. Anyhow, so here there's a parameter control scale. You can set it as true. So then you get, oops, we get it, control scale. Okay. Yes, so control scale true. So then you get this neat scale bar that's also dynamic. and it gives you in kilometers and miles the scale. So that's quite handy. Handy to give more information to interpret the map then. Okay, so volume map, then additional parameters, and of course all the available parameters you can then check from the documentation. So there's plenty of more. I haven't tested all of these in practice, but you can then experiment if you have some specific case you want to produce. So we will, for example, then change the background tiles in the next steps. Good. So I guess then we are ready to move. This was just a slot to, so what happens in here, we create the map instance, store it in this variable, and then now we have it in memory. If I want to plot it again, I can just write M and then proceed with that. Maybe I want to zoom out a bit, actually. Start zoom 10. Let's do that. That's fine. Just run it again. So now I have some map instance stored in the variable M. And if I now would want to take this interactive map and send it to a friend, how to do that? So we can store this to file, and let's have a look at what kind of file. So out fp base map. So we will actually write it to an HTML file, and we'll have a look what that means in a bit. So map.save output file name. You can run that, and then you should see in wherever you stored it, this HTML file. If you double click it, so open that file, you will actually see, well, you might need to trust the HTML. So Jupyter Lab is able to render that file. So it's now locally on your computer. And you could also, if you're working on your own computer, you can drag it to a web browser and then see the interactive contents. Then I think we can open with editor to see the actual definitions. So this is now kind of the source code of our interactive map. You don't need to understand too much about it. I don't either. Maybe one of our students who has been working with JavaScript and maybe even Leaflet can enlighten us more. But if, for example, you look a bit more closely what's happening in here, so you can see that there are these references to the Leaflet library, which then compose the different interactive map elements in there. And then there's definitions of the background map and so on. And even if we would add data in a volume map, then the data would be stored in this file. So be cautious in there. Then there's, of course, more clever ways to store the data somewhere else. So inside there's the map object, for example, center coordinates, coordinate reference system, and that gets added to the map instance. Okay, great. So let's then see how we can add some data, or actually first we will see how we can change the background tile. So let's create or recreate our map. Volume map location. You can copy paste from before, but I'll just now write it in here. We can, for a change, take some other location. Let's see where this takes us. So at 40 latitude, then -73, so somewhere westwards. Then there was this tiles. And you can then check the documentation for multiple options and the exact syntax to refer to the different tiles, or tile styles. But then we can, for example, take kind of a stylish tile set from Stamen, add some additional parameters. You can also, you don't have to do exactly the same that I'm doing. You can experiment. Put your hometown location here if you remember the coordinates. And now I define it, then I need to actually print it out. So we are now somewhere in the United States, near New York. And we have this stylish Stamen background map. So a bit same than with contextually, we can then adjust the map tiles, and here's a short list of these predefined providers, and then also if you have some tile service or some predefined tile service, you can then pass the URL to the custom tile set using the tiles parameter. Yes. Okay, so then now we have only worked with the background map, nothing we have self-analyzed or created, just zoomed in the predefined map tiles. So let's add a simple marker, just a self-defined marker on the map. I will go and copy paste this Helsinki syntax as my base map. Recommend you do the same. So create the map instance, meaning this. So I create this map object, zoomed into Helsinki with some zoom start. Maybe we can actually, I think this should be closer to Kumpula, if I remember correctly. So 60.20, 24.96. I tested that before. So that will produce the background map that's zoomable, that we already know. And then in volume, we have another type of object, which is called the marker. So that we create by calling the marker constructor. I will now put these parameters on separate lines. So, so marker refers to a dot, just a point of interest on the map. So we can define a location. Let's copy paste from there. So a list of coordinates. Then let's actually check. I think in here. Yes, so in the order of latitude and longitude, northing and easting, and I think the same applies for the marker. So northwards, decimal degrees, and then east-west. And then for the marker, we need to specify, let's see, we probably can already create the marker just by defining the location. So this one creates the marker object, and then we should somehow, a bit the same that on the static map, we're plotting into the same figure object. So here we are adding objects to the same map instance. And in volume, it goes like this: add to, and then reference to the map. Map instance. Let's see what happens, and then finally I will print it out. Okay, so we have the background map, then we have a point somewhere in Vallila. Can adjust it so that it goes to Kumpula by cheating from the lesson materials 4 to 6, and then that is. If you want to have it exactly on the campus, well, it went to exactum, but that's good enough for the location. So now we have this marker object in there. Then we can add a pop-up. So Kumpula campus, for example. And then we can modify the icon. So icon is yet another volume object. Capital I with the icon, and then from there we can adjust the color. And then there are these different predefined icon visualizations or icons. Let's see what we got from there. I try to keep everything visible on the screen. So now we have this green icon in Kumpula, and we defined the pop-up. So if I click on it, I get Kumpula campus. So this is now this manually added marker. Just if you're just marking the venue or one single source location or whatever, you can just manually define it in here. While you're still typing that in, I will quickly check if there was something. Again, latitude and longitude. For remembering, which is at least for me as a Finnish speaker, it's, and maybe for everybody else, it's the constant trouble of remembering which one is which. And there was this one nice kind of memory rule that if you have latitude, which is the north-south direction, so at some latitude, well, it's a stupid example, but there's some song about latitudes and attitudes. And if you're at kind of southern latitudes, you have a relaxed attitude. And then if you're in the north, you have very kind of uptight attitude. So latitudes and attitudes change in north-south direction. Maybe that helps some of you to remember. Moving on then to actually adding our own data. So this is of course cool, but it's not yet related to our pandas and GeoPandas data frames. So let's proceed to reading in some data. You can just run that cell to check that you had the data in the correct folder. So we bring in our familiar address points that we have been geocoding and visualizing also during the previous weeks. And let's just points head check the data. We have these addresses that you might remember represent public transport stations, some ID, and then the geometry as shapely points. And you can see that it is in VGS 84. And here, pay attention that we have latitude, longitude. So the 60 is the north-south and 24 is the west-east. And here is room for mistake. In shapely, we have the coordinates other way around, and then to volume, we pass them in a reverse order. This applies also to, what is it? Some other Python packages that deal with geographic coordinates or coordinates in general. So always read the documentation. In which order does the tool want you to pass the coordinates in? Latitude, longitude, or longitude, latitude. That's the by far the most common mistake with any kind of coding with geographic data. Yep. So then I think this is a useless code cell. So let's go under convert the points to GeoJSON features using volume. So here we need to do some steps in order to get our coordinates into the correct order and to add them to our map object. So the next couple of points might require some concentration. Let's create a variable, points, GeoJSON, something like that. And then using volume, we can create these features that we can then put on the map. We'll first create it and then see what it is actually about. So bottom line is that we need to have a GeoJSON representation of the points in order to add them to the map. So for this constructor, we will pass the points, which is now our geodata frame as a whole. And then we can give it a name. We can call it PT stations. public transport stations. And then I have some kind of name. Yes. So passing the points, and then this is optional parameter. And let's see. Oops. So then we have a bit of a more complicated representation of our same data, but this is basically now, if you would save the data as a GeoJSON file, you would have something like this. You have the whole thing, and then in a dictionary, you have these different properties of the points, all the coordinate information, and so on and so forth. But in such a format that we can then proceed with and give to Folium. I will comment this out because it's quite long and messy, but if you want to inspect it further and understand more deeply, you can then look at the actual GeoJSON representation of our data. Yep, and I think text refers to population data. It's actually, oops, address data. So then we have the map instance, and we have these points. We will have to we don't necessarily need to create the map instance, but just to follow our example, so I will once more copy this kind of base map. Sorry for jumping up and down. So again, define, if you want to change the definition of your base map, the zoom location, zoom start, and so on. So we can adjust these parameters. It was now geared towards Kumpula, so this might be a bit more central to Helsinki. And then we have the GeoJSON version of our points. So I think I have it with point GJSON, and that is now a Folium object. So it has, similarly to this marker, it has this function add to map. And then I can print out the map. That's how it goes. It's maybe still a bit abstract what happens in here, but basically we convert the points into such a format that can then be added to the map without a problem. So then from this GeoJSON representation, Folium is able to pick the latitude and longitude coordinates in the correct order, create markers for each point, and then show them on the map. And then, of course, we could add tooltips and so on. Okay, in the next, I hope you were able to type this in. If I'm going too fast or too slow, you can just type in too fast, or there's this go slower and go faster buttons as well. So now for this one, we will take a little sidetrack and add some of these map elements. So we, of course, yet have only one layer, but at this point, we can already demonstrate how we can then control the layers that we have in our map. So we introduce another Folium object type or class, object class called layer control, which goes like this. So we construct it and add it to the map. And you can check additional documentation, for example, for changing the position of the layer control icon and so on from the documentation, but already by simply adding the layer control object, we should be able to add it there. Okay, I have my zoom window blocking the view. Let's see if I do like this. So now you can see the points in there, and when you click on this, you can then switch on and off the layer. So especially with these interactive layers, it's good to do proper selection of features to plot. Don't have too many, but sometimes you might then have alternative layers plotted in there, and then the user can hover, choose which ones to view against the base map, or a combination of layers then afterwards. All right. So then we have the points, and this is already a nice map, especially if we would add some pop-ups or some other interactive elements. But we can also do a kind of analysis or exploratory visualization using Folio in the form of a heat map. And this one requires then a bit further data wrangling. In order to plot the heat map, let's actually check the documentation. So the heat map constructor wants a list of points of the form latitude, longitude, or with a weight also, but we will stick to latitude. So latitudes and attitudes, the north, southwards, decimal degree coordinates, and then longitudes. And then there's some additional parameters, but this is our goal. And as our starting point now is this data frame, which is called points. We have a shapely point object with now longitude, latitude. So we can't simply put these point objects as such into a list, but we need to we need a list of, list of points, kind of list of lists with then even the coordinates flipped around. So it's maybe a bit late in the day to figure this out on your own. So let's walk it through together, and then I hope you return to this and try to still further understand what's happening later on. And here we will use now the lambda function that we have used a couple of times before. Let me see if I can get my video back in here. Sorry. There, just for the lesson video. Okay, so let's go. We would need a list of list of yx points, if we put it like that, maybe easier to understand. So let's do it so that we want to, for our points data frame, let's create additional columns where we pick the x coordinate and we pick the y coordinate to separate columns, and then we can list those in the reverse order. So points x, and points y. Just creating new columns, and we want to fetch the xy coordinates from there. And how to do that? We have points geometry, and these are shapely objects. And I think actually, well, maybe I'll just a quick improvisation. I check if I can even do like this. Yes, I think it's even simplest to do it like that. So in the lesson materials, I'm using the lambda function, but now that I think of it, we can just simply do this. So as we have a geodata frame, or geo series, actually in this case, if referring directly to the geometry column, we can get all the x values, and then we can get similarly all the y values into separate columns like this. Let's check how it looks like now. So we have the X, so east, west, and Y, north, south, towards coordinate. And then we want a list of those coordinate pairs. So one way of doing that quite efficiently is to use this zip function we have met before, and then to do this, put these in the correct order. So now we want to flip the order, Y and X, and this would return a zipped object. And if we list those, we get, well, these are now tuples, but it's good enough for the heat map. So now we have a list of coordinate pairs as requested by this volume heat map function. There we go. Okay. Well, there was a slot for checking the data. If you want to print it again, you can do that. So our data frame is not so long. We can verify that all of the coordinate pairs look correct. So then finally, that was now the hard part, and then we can do so that we well, we can create a fresh map instance by again copying our base map in there. Now in the memory we have those points. And then here we want to import the HeatMap plugin. It's a bit more complicated than the simple constructor. And then the syntax goes like this: HeatMap locations add to our map object, and then show the map. There is some alternative syntax. I didn't now test this. I think 1 year ago, some of these volume syntax changed, so I'm not sure if that works anymore. Feel free to try. But what we get is now a heat map. So where it's more red, there's more points close to each other. And this also changes dynamically if we zoom in. Of course, then if you want to make like control what is the actual interpolation of the data, then maybe better to make a static map with more details. But this is quite a good quick visualization of showing where there's more data, less data. And we just have to wrangle the data so that volume is able to plot it then using a leaflet. All right, time flies today. Let's see, we can still go through some of the examples. I will maybe skip the next one. You can or scroll it through from the website. I apologize. This was one of the feedbacks that it's boring if I skip stuff, but let's try to stick to the time. So similar way, we can create this kind of clustered point map. Marker cluster is the plugin name. Create a base map. Do the same trick. Here we can indeed just call geometry.x. Don't even have to do this lambda function. Zip the points, list the points, locations. We actually already have that in the memory. And then pass that to the marker cluster, add to the map. So then it depends a bit on the phenomenon you're visualizing. But if you zoom out, you can see that, okay, there's 35 points in Helsinki. Those could be field observations or responses to a PPGIS survey or whatever. And when you zoom in more, you can see what's happening. And then sometimes you see when you hover over, you see these polygons. So that's kind of the convex hull for the points that were rendered on the map. Okay, so you might consider doing something like this for the exercise this week or in the final exercise if your data fits this kind of visualization. And same as before, you could add layer control, change the background map, and so on. But let's still go through together this Choropleth map plotting. There's again this familiar syntax for fetching data from our HSY web feature service. It's already now using a bit old data from 2018, but that should be fine. If you just run this cell, you should get the data from there. I will maybe try to, in the last week, talk a bit more about these web feature services and things using QGIS as well. But we have now our familiar grid data. Columns are in Finnish, but main focus is this asukkaita, which is the population per grid. And then again, when plotting data, it's important to pay attention to the CRS. So in this cell, we have now the data in this variable data.crs. So you can actually see that there's no definition. We could have defined it when reading in the data, but we haven't now. But from the documentation, we know that the CRS is EPSG 3879, one of these Finnish coordinate reference systems. So using this CRS object from PyProji, we can then now define the CRS as it's missing from the layer. EPSG 3879. Okay, let's verify data.crs. Print. So now the definition is there. It matches our coordinate values in the original data. And now that it has a definition, we can reproject the data. And actually, well, here we're reprojecting to VGS84, but I think, and it is true that Folium is then able to take those coordinates as before and then put it into the kind of web Mercator projection on the fly. So let's reproject the data to CRS EPSG 4326. So latitude, longitude coordinates, verifying that. I'll actually do a new. I'm speeding up a bit, but I hope you're still with me. When speeding up, then come the typos. So now we have our grid data in EPSG 4326 that then Folium is able to handle. I could have left this in, but if you want, you can on the fly rename some columns. So let's rename only the one we're interested in. So this asukkaita, ASUKKAITA, refers to POP 18, so population in 2018. That should be a dictionary. So this we know already how to do. And then I'm actually, well, let's do it this way now as instructed. So when later on plotting, it's easier then to understand when we're actually plotting the thematic map, but we need some kind of an ID, or we need to verify that the data has unique IDs in one of the columns. So let's create a new column for the plotting purposes called GeoID. And basically, if we look at the data, we had the kind of unique index in the column. I think we could have also used this index in here, but we might as well create a new one, which runs from 0 to the length of the data frame by taking the actual index, so data.index, and then apparently needs to be a character string. So now we have a new column in the data frame based on the index of the data as character string that we can use when plotting the data. And then we continue with this GeoID, then this renamed population count column and the geometry column like that. And then I have some, I didn't maybe run this one. No, now that I start to be split yes, so I'm missing, trying to speed up and then I miss. So you need to specify that you're renaming columns and then the dictionary. That's what I was missing. There we go. So data rename columns equals to the dictionary, and then we were successfully renaming the column. We have an ID column, population column, and then the geometries, which are now in VGS 84. Not really. Let's see. Okay, well, let's see how it goes. Let's blame it on the time of the day. It's actually now, yes, now it looks better. So there's always a risk when rerunning these cells in the notebook. So now my coordinates look correct. Yep, so I have them in VGS 84. So again, good reminder to pay attention on the reprojections that they go correctly. Fine. So we are now ready to plot the Choropleth map, and I want to show this because it's probably something you will want to do in the exercise. We will be creating the map using this Folium Choropleth class. So once more, let's define the base map instance. You can copy paste from before or then type in with me somewhere around Helsinki. We can then change the tiles maybe later, but that should do. We can do zoom start. Okay, something to work with. And then we use this Choropleth instance. You can, of course, check the documentation for further details. Maybe we also want to do that. I wonder if I put the link in here. So let's check a bit. Okay, that link doesn't work. So we can find from here. No, okay. I will just explain it myself. So as this one will have quite a few parameters we can control. So let's at least type in the useful ones. Sorry, trouble with the zoom. So we start by passing a parameter called geodata, and there we actually pass the geodata-frame. So that is able to read in our geodata-frame. And then we can define columns. And here, this is related to the comment in here. So we need to pass the ID column, so the unique rows, and then the actual values that we are then plotting. So for each geo ID, there will be a unique geometry, and then pop 18 will be the attributes. And then I think we still need this key on feature ID. So basically, as I understand it, Folium will read this kind of geographic data from here and then bin or key the attributes based on this geo ID to our geographic features. We could even try if we are already able to view the map based on these things. So there's the Choropleth constructor. We pass in the geodata, then the attributes, and then the link between the attributes and the geodata, and then add to map. Might be that we still get some error, and then we print the map. Okay, so at least we can see our grids. So these are the populated grids in the Helsinki region visualized on top of our base map. And that's excellent. And then we can start modifying this. So let's see which one of these parameters. Let me just test quickly. I think it's this data one now that I didn't find the documentation. Yep. So in addition to the geodata, we want to pass the actual data. So in addition to the previous one, we defined the actual attributes using this data parameter. And then here we further define the columns. So this then creates our thematic map, but with some default classification scheme, default colors, and so on. So that's already quite informative and logical. We have the dark shades in here where there's probably more people living in. But as we might want to, we can then, for example, adjust the fill color, which is then yellow, orange, and red in our example. So yeah, that might be a bit more appealing for highlighting the hotspots in terms of population. And then there's other parameters for adjusting the grid outline colors, the line width, and so on. But those, maybe we can actually, I'll add this line weight. It's maybe a bit. So we have this line weight equals 0 if you, for example, want to get rid of the outlines completely and just have this surface visualized like that. So then at this point, it comes back to the cartographic choices. This wasn't maybe the best one, at least against the chosen background tile. So of course, then we could go back to the adjusting our base map, which happens in here. And in the lesson materials, we have used this predefined tile set from CartoDB, which has a bit less color, which then brings more of the focus on the visualized data, and so on. Okay, so you can continue experimenting with this. In the final exercise, I will stop here with the typing because I have been a bit slow. But then there is, oops. If you check from the web pages, there is one additional snippet for adding tooltips for our polygon data with a bit more advanced options that you can then add information if you hover over the hover over the polygons. But this is a bit advanced feature if you want to try it out in the exercise for this week. Okay, great. I would still want to reserve some time for explaining, once we now have these either PNG maps, static figure files, or these interactive map objects, you can store those in HTML files. How could you then put those to GitHub and publish them so you get a link that you can share, for example, to Slack, or then to whomever, or put on your website. But still, with these interactive maps, if you want to experiment, you can then try, for example, Plotly Express has quite a nice looking option for plotting Choropleth maps. It has a bit similar idea with the GeoJSON tinkering to start with, but I think this, for example, looks quite appealing also then with these tooltips. I'm sorry I didn't have too much time to go in detail with these tooltips, but it's maybe also best that you first plot the basic elements and then start adding more complexity in there. Okay, so looks like we don't have time to go through this case study, but that's fine. Basically, it repeats the things we just did with a bit of additional flavor. You can find the notebook in the CSC notebooks and go through it together. And it's also a bit similar as our case example last week with the hospital districts. So in this tutorial, we read in some regional employment rate data from a CSV file. We modify that data frame so that we can then join that information to spatial layer that we read in from a web feature service. We join the data. We again do some manipulation with the common key, merge the data based on this common attribute. First, just make an exploratory plot on these employment rates across Finland with a better classification. So darker the color, higher the employment rate. And then finally, creating an interactive map using this Choropleth method that I just showed. And then adding these tooltips. So basically a GeoJSON object, which then has this. The style function is a bit, maybe I can try to come to the practical sessions to explain this a bit further. How to create this hovering tool. But we indeed, in this tutorial, add the tooltips in there, and then furthermore, gets a bit more complicated, but you can also in Folium adjust the classification scheme. So of course, if making cartographically correct, or at least appealing and in a way justified visualizations, it's good to think about the classification scheme. The syntax is a bit, I don't know, messy, but a bit at least more lengthy. So then this one then adds a bit of options for creating a custom style for our interactive Choropleth map. Good. But the kind of main learning goals from this lesson is to know the basics of plotting map layers in a static map, controlling the coordinate reference systems, getting the maps into the same figure, thinking a bit about the cartographic elements, map legend, choices in terms of layers, and then the same for the interactive maps, to be able to have a base map, some points, maybe polygons in the same figure, and giving some thought on the phenomenon that you are visualizing. So that is the core learning objective, and then you can, according to your interest, experiment a bit with these different options in the weekly exercise.